These foam boards look similar, but their internal structures create different moisture pathways. Does only one absorb water? The real answer is more useful and more complicated than a simple yes or no.
Both are polystyrene-based rigid foams, but manufactured differently. EPS is formed from fused expanded beads. XPS is produced through extrusion, creating a more continuous foam structure. Same polymer family, different process.
Under magnification, EPS shows closed cellular regions within individual beads, plus interfaces between those beads. XPS typically has a more continuous closed cell structure. Structure changes the paths, but this is not an absolute waterproof boundary.
Both materials can take up some water under defined test or service conditions. Product formulation, density, edges, damage, immersion time, and test method all influence the result. Both may take up water. XPS should not be described as absorbing zero water.
Water vapor diffusion is different from liquid water absorption. Vapor permeance depends on the exact product and thickness. It should not be inferred from appearance or from the words closed cell alone. When foam becomes wet, drying behavior depends on where the water sits, how long wetting continues, surface exposure, temperature, facings, and available drying paths. Lower absorption does not guarantee faster drying. Real performance also depends on joints, cut edges, fastener penetrations, damage, facings, drainage, and workmanship. A laboratory value does not describe the entire wall by itself. EPS and XPS differ in manufacturing and cellular structure, which can change moisture behavior, but neither is perfectly waterproof, and neither is universally better. Compare structure, product, thickness, test data, and complete assembly. Let us correct a common myth. The claim that XPS absorbs zero water while EPS soaks it up is misleading. Both foams can take up some moisture. The right question asks how much, under which conditions, and in which assembly. Think of moisture as three separate stories: liquid water absorption, water vapor diffusion, and drying. Each follows its own rules. Mixing them together is where marketing claims often mislead. Numbers matter, but only with context. A single absorption percentage or permeance value has meaning only when paired with a named product, a stated thickness, a specific test method, and defined conditions. General educational information only. Moisture performance varies with formulation, thickness, facings, condition, test method, exposure, and the complete assembly. This is not a product recommendation. Verify manufacturer data and local requirements with qualified professionals.